All right, we are on page 57 of your student companion. We are doing a launch. It says the city's second best scientist likes to look overly complex. That's why he's second best. He presents the cost of a rocket bolt on rocket 1 as shown. How much does each bolt really cost? Show how you know. So here's the rocket, and we have a big old fraction right here. And then it says dollars each. That means after we simplify this fraction, this big old fraction, we're going to figure out how many dollars each bolt is. Well, just how we did yesterday, we can cancel out a lot of these numbers. So if we notice there's a 5 on top and there's a 5 on bottom, we can cancel both of those out, and that gives us a 1 and a 1. And then we're like, oh my gosh, there's also a 6 and a 6. Cancel those out. There's a 2 and a 2. Remember, I'm putting 1 because that's what we're replacing it with, because something like 2 over 2 equals 1. 17 over 17 equals 1. 31 over 31 equals 1. And 4 over 4 equals 1. So what do we have left? We have nothing left on the bottom, and we have 4 on the top, which means each one of those bolts actually only costs $4 each, not all of this big fraction. So let's do our reflection. What was the key to solving this problem, and explain? Well, the key to solving this problem was just simplifying our expression. Simplifying our expression. And that's kind of what we use when we are working with division of exponents, is just a bunch of simplifying. We might have 10x's up here and 5x's down here, which gives us 5x's left over. So that's what they wanted you to take from that. Okay, take a moment now and write division properties right underneath your launch. Pause me here, and then we'll talk about them. So pause here. And you should have all of these written out, all of these division properties. And again, just like multiplication properties, we're going to kind of make like a T-chart. I'm going to give you an example over here, and here's your definition. So it says dividing powers with the same base. To divide numbers or variables with the same non-zero base, just subtract the exponents. So this is what I'm going to have you do. Here's an example. Let's say it's x to the 5th power over x to the 3rd power. Well, that's going to give me x to the 5 minus 3 power. Well, what is 5 minus 3? It's 2. That gives me x to the 2nd power. And as you saw yesterday, if we wrote 5 x's out up here and 3 x's out down here, we'd have 2 left over, and they'd be on top. Well, what happens when it's negative? Let's try another one. X to the, let's switch it, 3rd power over x to the 5th power. Well, we still do the same thing. We always subtract the bottom from whatever's on top. So this would be x to the 3 minus 5. We flip-flop them. Notice the difference. Well, now this is x to the negative 2. But we don't like negative exponents. And we learned yesterday, when we have negative exponents, we flip them to the bottom of our fraction. So this is now 1 over x squared. So look at the difference here. The top, this is our answer is x squared. The bottom is 1 over x squared. All right, let's look at the second type. The second type is power of a quotient. To find power of a quotient, raise the numerator and the denominator to that power and simplify. So this example I'm going to do in red, and my example is going to be x squared over 3, and in big parentheses we're going to raise that all to the 4th. So just how in multiplication, we're going to kind of give each factor on the inside the power of 4. So remember, we like to see this step, x to the 2 times 4 over 3 to the 4th. And on the homework, it's actually going to have you do what 3 to the 4th is. So x to the 2 times 4 gives me x to the 8th. And 3 to the 4th is 3 times 3, which is 9, times 3 is 27, times 3 is 81. So that would be your final answer, let's say on your homework, and they'll ask you to put a number down here. So those are your division properties and some examples. go ahead and flip your page to page 58. All right, it says simplify the expression. So we have g to the 35th over g to the 23rd. So that's going to give us g to the 35th, and we subtract our exponents, minus 23. So that gives us g to the 12th. 35 minus 23 gives us 12. And that's our final answer. All right, so why don't you try? And the you tries are both on page 59. So flip there, try 1 and 2, and see if, pause me here, see if you get them right. All right, you should have gotten x to the 14th for 1 and x to the 23rd for 2. Remember, both of us, both classes, we want to see this step here where you actually subtracted your exponents. And if you want to put these in parentheses so you're not getting confused, that's fine. Okay, let's move on to the next got it, page 58. Does a to the 12th have the same value of, a to the 12th over a to the 8th have the same value as a to the 6th over a squared? Justify your answer. And we had one of these on our last video. And a to the 12th over a to the 8th is a to the 12th minus 8, which just gives us a to the 4th. And basically we're saying, is this the same as this? So a to the 6th minus 2 also gives us a to the 4th. So yes, these are the same. All right, next one. Simplify the expression. A squared over ab to the 3rd, all of that to the 4th. So we're going to take this 4 and we're going to distribute it to each of these. So we get a, and remember we want to split this up so we can have enough room for other ones. A to the 2 times 4 over 4b to the 3 times 4. What does that equal? Well, a to the 2 times 4 is a to the 8th over 4, and then we have b to the 3 times 4, which gives me 12. And that's it. That is our final answer. We cannot do anything else to that. Now, they're not giving you any examples of what happens when there's negative exponents, so I'm going to do one right here, and then I'm going to have you try or you try. So I'm going to do an example here of a negative exponent. Okay, so next to your got it, I want you to write this example. We're going to do basically another got it because this one has an example of negative exponents, which none of the ones in here do. So first things first, we want to distribute this 2 to each one of the factors inside. And we're going to flip this one all the way down. So that gives us 4 squared times x to the 3 times 2 over, because remember we're giving this 2, maybe we should change its color. We're giving this 2 to each one of these. So on the bottom we have 2 squared, because it gets a square, times x to the 5 times 2. All right, so there's our first step. Our second step is going to be actually to, solve this out. So this is 16x to the 6th over 4x to the 10th. Well, now we have some other things that we can do. First off, we can do these numbers up front. As Miss Winkett would say, these are your old school numbers. You solve these old school. And then we have these exponents that we can subtract. So our old school number, 16 divided by 4 gives us a 4. And then we get our x to the 6th minus 10. Well, x to the 6th minus 10 gives us x to a negative number. We get 4x to the negative 4th. We really don't like negative exponents, so that, just the x to the negative 4th, gets flipped down to the bottom. Our final answer is 4 over x to the 4th. And we are done. All right, so now flip to page 59 in your student companion. And I want you to try what I'm calling the U tries. It's 3 and 4. And I also want you to add 5. Of course, this 5 here is giving an emphasis on those negative exponents. So pause here and see if you get them right. All right, so first one, you should have gotten 8r to the 27th over 27m cubed. Down here, you should have gotten 32d to the 15th, g to the 60th over 1024, s to the 60th, w to the 30th. Remember, this is 4 to the 5th power, not 4 times 5. Number 5, there was lots of steps. So you first had to distribute this 2 to all of your little friends on the inside. Then you had to subtract 6 and 10. You got 9r to the negative 4th. Well, we don't like negative exponents, so we flip it down and we get 9 over 4r to the 4th. Notice how I didn't flip the 9 and the 4. The 9 and the 4 stay. I only brought down the r to the negative 4th. So if you didn't get this, this is a harder problem here, but there will be some like this on the quiz tomorrow, so make sure you get how to do that before the end of class today. And start your homework. It is 3-4 on digits 1 through 15.